Now we're going to talk about the arithmetic sequence. And you should have already written the definition for this in your journal, but it reads, a sequence, AN, is an arithmetic sequence if it can be written in the form A plus D, A plus 2D, etc., A plus n minus 1D, etc., for some constant D. The number D is known as the common difference. Each term in an arithmetic sequence can be obtained recursively from its preceding term by adding D. So we have the formula down here, AN is equal to AN minus 1 plus D for all n greater than or equal to 2. So these are all the elements or the terms in our sequence. A is A1, A plus D is A2, A plus 2D is A3. And this is, as it's written here, it's an infinite sequence. And that's, again, what those dots tell us. Now, we've already talked about what it means to be a recursively defined sequence. And that means that each term or each element depends on the one before it. And that's what we've got in this formula down here, that AN is equal to AN minus 1 plus D, so AN depends on AN minus 1. Now, there is a general formula that we can use for figuring out any element in an arithmetic sequence if we know what A1 is, the first term, and we know what D, the common difference, is. And that formula is AN is equal to A1 plus n minus 1 times D. Now, being that we're in calculus, you should ask yourself where this formula comes from. So let's consider the A4 term here. Now, our definition down here tells us that the A4 term is going to be equal to A3 plus D. But what's A3 equal to? Well, A3 can also be defined recursively, and that's going to be A2 plus D. So if I substitute back in, now I have that A4 is equal to A2 plus D plus D. But you have to ask yourself, what's A2 equal to? And again, our formula over here tells us it's going to be the term before it plus D. So if I substitute in, I've got A4 is going to be A1 plus D plus D plus D. And A1 is the first element in my sequence. I can't substitute in for that, but I could clean this up by writing it as 3D. So I've got A4 is equal to A1 plus 3D, and wait a minute, if n is equal to 4, 3 is equal to n minus 1, and that's the general formula that we started with. So let's look at a couple of arithmetic sequences. I'm going to change ink color up here, but I also need to change the thickness of my pen. And the first sequence that we're going to look at is pretty simple, 3, 7, 11, 15, 19. And this sequence is going to be finite because it doesn't have that ... It only has 5 elements or terms in it. And if we look at this, what's A1 going to be equal to? Well, A1 is that first term or that first element, and in this case it's going to be equal to 3. Now how about D? D is again that difference between consecutive elements, and what's it going to be for this sequence? Right, it's going to be 4. Well, if I wanted to write the general formula, I could substitute in the information that I have. So remember, my general formula is AN is equal to A1 plus n minus 1 times D. So if I substitute in here, and I'm just going to move this down a little bit, A1 is 3. I've got n minus 1, and that's going to be times that common difference, which is 4. And if we do a little algebra here, we're going to have 3 plus 4n minus 4, or a general formula of 4n minus 1. And that is the explicit definition of my sequence because it doesn't depend on the element before it. All right, I'd like to look at one more example here. And again, I'm just going to change ink colors, which means I need to change the thickness of the line. And this whole idea of the general formula of looking at sequences holds for negative numbers as well as positive numbers. So let's consider a different sequence here. It's still going to start with 3, but then my elements go on to be -2, -7, and -12. Again, this is going to be a finite sequence because in this case it only has 4 terms. And you tell me, what's A1 going to be for this sequence? Right, it's going to be the first term, which is 3. And then how about D, that common difference between the terms? Yep, it's going to be -5, which is a little different. We haven't looked at a sequence with negative numbers yet, but the same rules still apply. And if you're just careful with your negative signs, if you respect the negative signs, the algebra will help you come out with the right answer. So if we wanted to find this general formula here, again, we have our formula. AN is equal to A1 plus n minus 1 times D. And I can substitute in. So AN is going to be equal to A1, which is 3, plus n minus 1 times D, which is -5. And I just need to be careful with my algebra. So I've got 3. It's going to be minus 5n plus 5 in this case because I've got 2 negative signs here that I'm going to multiply together. So I end up with a general formula of 8 minus 5n. And that's going to be my general formula. Again, this is the explicit definition for this sequence as opposed to the recursive definition of the sequence, which would be AN is equal to AN minus 1 minus 5. So next we're going to do exercise 13, which puts all of this into action.